Hello. Good
Hello, are
morning,
we ready?
everybody.
Go for it.
Good morning, everybody. Welcome to the 28th Measures Health Virtual Seminar Series organized by Ghana Medical Agency, GCRF African SWIFT, and KAUS. This early morning, we'll be talking about understanding, predicting, and communicating high impact weather events across Africa. With this event, we are going to talk about how forecasts have value when it is skillful and useful. Also, we are going to talk about the skill side of science in sub-signal prediction, and we are going to take the time scale from 2 to 4 weeks. We are also going to talk about the useful and usable forecast tools which supports real life decisions, and also we are going to use the co-production approach in the GCRF SWIFT Africa project to also confirm these predictions. The guest going to take us through is Dr. Linda Hirons, who is a senior research scientist at the National Center for Atmospheric Science, NCAS, and he's also based in the Department of Meteorology at the University of Williams. Dr. Hirons, please, you're welcome.
Thank you. Thank you for the Yeah, I'm going to do that.
Sure.
I'm going to do that now. Okay, can you see my screen?
Yes, please, I can see the screen.
Brilliant. So thank you very much for the kind introduction, and thank you for the invitation to come and speak to you today. Please do highlight in the chat if you are struggling to hear or not following, and I'll try to keep up with that. Okay, so I first wanted to back actually to my last time that I was at the KNUST. My previous seminar here was in 2012 in person. This is the piece of paper up on the board. Sylvester there was chairing it. And here's a few pictures of that seminar. So I have no idea if any people here today were also at that talk back in 2012, but I'm very pleased to be speaking with you. Okay, so today, as has already been introduced, I'm going to talk about where forecasts have skill and where that overlaps with the use and how they can be useful, a co-production approach. Some examples of skill I'll cover, and some examples from the SWIFT project in terms of the application. I'll then talk about some new projects and new opportunities. So on one side, we have skill. This is where forecasts are skillful, where, why, and when they're skillful, trying to understand the sources of predictability, the regime dependence of that skill. And then on the other side, we think about where forecasts are useful, how they can support decisions, how they can build resilience, and how they can help people in the region that are using those. And from the skillful side, we really think a lot about the large-scale drivers. Do we understand the large-scale drivers? Do we understand how they influence African weather? So on sub-seasonal timescales, this might be the Madden-Julian oscillation. On intra-seasonal timescales, this would be the El Nino Southern oscillation or the Indian Ocean dipole or land surface conditions. So do we understand these large-scale drivers? But do we also understand the link between those large-scale drivers and local weather? And then can we model those? Are we able to capture the large-scale driver, and are we able to capture the local response? So there's a lot to think about in terms of the skill side of the forecast. There's also a lot to think about on the application side. Can we make forecasts that are useful? Are they fit for purpose? Do they serve what they were designed to do? Are they usable? Are they communicated in ways that are clear? And are they accessible to people who need them? And are they actually used? Are they trusted? What's the legitimacy of the people producing them, or the agency of those, the control of those producing those? And we'll talk a bit more about this in the SWIFT project, and I know some of you are probably involved in that. So I'm really interested in where these two parts overlap, where forecasts are skillful and where they're useful. And it's in this place where they overlap where we can develop we can co-develop climate services that are appropriate, accurate, and actionable. So I'm going to give some examples of that, and it's really a co-production approach which allows us to do that. And that was the approach we took in the SWIFT project, and I'll talk a bit more about that. But this is an iterative dialogue where you continue around this cycle of building equitable, trust-based partnerships, building common ground around understanding what the desired outcomes are and jointly defining those issues. So what are the decisions that need to be made, and how can we forecast to support those? Making sure those solutions are collaborative and inclusive, and that they involve the knowledge of all of those involved, so that they can be appropriate and communicated appropriately. And of course, we want to evaluate those, and we want to continue to go around this cycle. And I'm going to talk today about a particular context. So in terms of the spatial context, I'm going to be talking about Africa, but in terms of the temporal context, I'll mostly be focusing on the sub-seasonal, so 2 to 4 weeks ahead, so the extended range forecasts. And just this co-production approach, if we come back to this brings together different knowledge sources, different experiences, and different working practices to jointly develop new knowledge to address those societal problems. So in a forecasting context, we did this in the African SWIFT project, where we had sub-seasonal forecasting testbed as part of the WMO real-time pilot initiative. And this is where it was a forum where prototype forecast products were co-developed and operationally trialed in real time. So I'll talk about that because GMET were very involved in that process. And just coming back to this co-production approach, there's a lot of work gone before, obviously, and some of what I talk about is taken from the FCFA, Future Climate for Africa, Manual for Co-Production in African Weather and Climate Services. I was part of the FCFA envelope of projects as well prior to SWIFT, so this is part of the work that went into that. And in a weather context, a co-production approach really transforms the user's role from being a recipient of forecast information to being participant in how that forecast information is generated, having a say in how it's developed, how it's visualized, and how it's shared. So it really shifts that emphasis from being a supply-driven forecast product to demand-led, with the hope, of course, that it's more appropriate, more actionable, and more reliable. So I'm going to give an example first from seasonal forecasting. So let's think about seasonal forecasting, and I've kind of laid out these questions here around the large scale. The yellow ones are kind of underpinning science questions. The green ones may be modeling questions where we interrogate our forecast models, and the blue ones thinking about decision making. So are there large-scale drivers that influence African weather? And this is coming back to the regime-dependent skill question. So yes, we know, let's take an example of ENSO. So we know El Nino is a large-scale driver. We know it can be well represented in forecast models. We know if they have an El Nino, they're able to persist those conditions. So yes, we have a large-scale driver. Do we understand the link between that large-scale driver and local weather? So actually for El Nino and Africa, this is reasonably well understood that we have wet conditions in the east, often dry in the south. This is the example from 1997, and dry across the Sahel. So we kind of understand this, and are there times can we skillfully represent this in the model? So here's an example of lead time along the X, skill correlation up the Y. And you can see when you have a very active El Nino, the dark red line here, your dark red line is higher than the others. So your skill is higher in the forecast when you have this strong, large-scale driver. And does that help make decisions? Well, this was an example of where we were developing these El Nino outlooks back for the 2015 El Nino event within country offices. This is just an example for East Africa, but I have the same for other regions as well, where you have the outlook for temperature and rainfall, the potential sectors with high, medium, and potential risk in those sectors, and where from the from the literature, we can find evidence of those impacts previously. And this is So this is an example, and this was a consultancy example done with DFID, but I would say, was it useful? Apparently, I don't know which decisions it influenced. Was it usable? Well, it was very much disconnected from the users in that sense. We were only interacting with DFID, now FCDO, and supposedly used very widely, but by who? For what reason? So I think there's a long way to go. This was an example back in 2015, a long way to go before we're able to have that immersive co-production approach. This is more consultative, if you think about those spectrum. And maybe we've got the whole starting point wrong. Maybe people would disagree with how this is laid out, and maybe it should start with the local scale and what decisions being made at a local scale, rather than starting with the large scale. Maybe we should start with the local scale and how is that decision weather sensitive, and then go back through interrogating our models and our understanding of drivers in terms of whether we can capture the variability that influences that local scale decision. So this is something I'm thinking a lot about at the moment. And this co-production approach, where we have all different actors coming around the table, so forecast users, forecast producers, and researchers coming together to try and build that. So I'm going to take a few examples from East Africa on the skillful side, and then I'm going to jump to some of the SWIFT output, because that's got more of a West Africa focus. So this is an example of the Indian Ocean dipole, which is known as an interannual variability, and we know that biases affect the connections in climate models. So here, this is an example we know in ERA interim at the top here, although the same is true in ERA 5, that we should have these observed wind pattern in the equatorial Indian Ocean. We should get observed westerlies across the equatorial Indian Ocean. But if you look at this is CMIP 5, but the same can be said for CMIP 6. If you look at all of the models, many of these models actually, the observed ones are the greys and blacks here, all having westerlies in this region. But you can see many models actually have the winds flowing in the wrong direction, have easterlies in that region. And if the model is unable to capture the mean state of that oceanic basin, then this is a paper that was part of that Future Climate for Africa project, which shows that you're unable to get the thermocline tilt right, and it leads to a more positive Indian Ocean dipole pattern, more moisture advected into Africa at the equator, and a much wetter short rain bias. So this is an example of where the mean state in models has led to problems with the teleconnections of how large-scale drivers influence local rainy seasons. And I've got a PhD student at the moment, actually, who's continuing to look at this, and this is the updated version for AMIP and CMIP from CMIP 6, and the example from ERA 5. So you still have many of these models, especially in the CMIP runs, still having the mean equatorial Indian Ocean winds during OND flowing in the wrong direction. So this is a problem if we're trying to capture the teleconnections between the large-scale driver. Now thinking a bit more about the regime-dependent skill. Here's an example from a paper by a postdoc of mine at Reading, Felipe, who was working on the SWIFT project. And here we can see the linear regression between weekly precipitation anomalies and large-scale drivers. So at the top, we have the El Nino Southern Oscillation. Then we have the Indian Ocean Dipole. And then the bottom two are the two RMM indices that measure the Madden-Julian Oscillation. This is the major subseasonal variability that propagates eastwards around the equator and influences rainfall in the tropics. And you can see that there is some strong connection between these different seasons and the large-scale drivers. And particularly if we're thinking about the West African region, we can see some links with RMM1, particularly across the coastal regions. And if we're thinking about East Africa, there's some strong correlations here associated with the MJO in March, April, May, a season which is typically difficult to predict. So if we look at that in a bit more detail, this is now a skill assessment for these African models in terms of weekly precipitation, comparing 3 different models: ECMWF, the European Centre model with the UK Met Office model, and with the NSEP model. And you can see that obviously the skill degrades as lead time increases, but there are some regions where there's still significant skill, difficult skill at weeks 2, 3, and in East Africa, some parts even at 4 in the ECMWF model. So there is some hope that there's information there, useful information there, but it's how do we turn this regime-dependent skill into something that can be used. This is an extension of that work that shows where you can remove the modelled and observed linear response to these large-scale drivers. So there's a significant drop in skill. If we look here, the grey lines here are with no removal, and at week 4, extended lead time, if you don't remove, there's a drop in skill when you remove the MJO, which is the pink bar here, if you remove the MJO related rainfall pattern after week 1. So you can see that the drop in the purple, which is removing all of those large scale drivers, is mainly coming from this drop in the pink line, which is removing the MJO signal. And what we can do is we can actually test what happens if we put back into the model the observed linear response to the MJO. And here you can see that that leads to much higher skill at week 4. So it shows the role, if you have a poor response to that large scale driver, you're going to have weak skill at the extended lead times. There's a lot more information here, and this paper covers, it's a Pan-African paper, so I'd encourage you to go and have a look. Now thinking about the MJO, this is from a recent paper that I wrote with Ben Maybe at Leeds, thinking about how the MJO influences the East African region. And here's some examples that were done as part of the SWIFT case study, looking at the March, April, May rains in 2018, 2019, and 2020. And you can see here the black dots are what phase the MJO is in, with coloured in dots showing strong MJO amplitude. The coloured dots here are for cyclone tracks when the cyclones occurred. The blue bars here are the precipitation anomalies. So you can see these grey weeks highlighted are when there were very wet anomalies. And here we've got the longer term modes of variability, El Nino and the IOD at the bottom. And this is just a nice way to visualize all of those different timescale variability that are occurring and trying to understand what's going on and when you have periods of very heavy rainfall. This is some work on the REACH project linked with Oxford, which was also part of Future Climates for Africa. I'm actually going to, in the interest of time, skip over that. Encourage you to go and look at the paper, because I'd like to talk a bit more about SWIFT outcomes. So I've taken you through some examples of how the large scale influences Africa, and there's references to papers there that you're very welcome to go away and look at. I now want to talk a bit more about the subseasonal forecasting testbed, which we carried out as part of the GCRF African SWIFT project. And I know many people at GMET and at KNUST were involved in that project. So very happy to hear inputs from others in the discussion. But this was an example of where we used a co-production approach in practice. So just to give you the context here, the The SWIFT project ran from 2017 to 2022. It was a large consortium of many different partners across different countries in Africa. The focus countries were Nigeria, Kenya, and Senegal. And in each of those different countries, we had research institutions. So for Ghana, for example, it was GMET as the National Met Service and KNUST as the research institution involved in that project. So each of those 4 countries had equivalent National Met Service partners and research institution partners. And the GCRF African SWIFT project was given real-time access to the sub-seasonal forecast data for a test period of 2 years. This was part of the WMO sub-seasonal to seasonal prediction project. And there were 16 participating projects in that who were given access to this data, SWIFT being one of them, and 4PAC was another. So I think some may have been involved in that as well. But as part of this project, we had access to the data. So we took this co-production approach into practice and were trying to make sure we could show the benefits of having this real-time access to data. And I was the work package lead for this and leading the sub-seasonal operational testbed. So you can go away and read a bit more detail of this in the 21 paper. But we had different operational groups in this testbed across different sectors: health, food security, energy, agriculture. And as I've said, the orange countries here were the main partner countries. We also partnered with ACMAD, Pan-African organization, in looking at health, and also with ICPAC in East Africa, focusing on food security. So that each of these operational case studies has papers in their own right. So you can go away and have a look at all of those. I'm going to talk through just 3 examples from across the case studies. Before I do this, is kind of those case studies fitted into a larger testbed program of work. So this, as you can see, the co-production approach is in there. There's a lot of case study analysis. This is kind of a lot of the operational case studies. There's a lot of work going into this across the 6 different operational groups. And within each of those groups, during the period of, so each week we had new forecasts, extended range forecasts out to 2, 3, 4 weeks ahead. And within each of those groups, we were co-developing forecast products to be applied in their context. So if we just go back for Ghana, the focus country here. So Ghana, we were partnered with DMET, and then we partnered with MOFA, so Ministry of Food and Agriculture, in providing sub-seasonal forecasts through the National Ministry for Application in Agriculture. So I'll talk a bit about that, and I'm sure many of you will know a lot more about that than I do. But here's just an example of some of the things that were developed through that testbed. And I'll take you through a few case studies. So one of those is with ACMAD. So this is the African Centre of Ecological Applications for Development. And within that case study, we worked with the WHO, the World Health Organization, to supply bespoke multivariable subseasonal forecasts for meningitis vigilance. And this was because we knew that links between environmental conditions and meningitis. So we knew that when you had hot, dry, dusty conditions, you were more likely to have meningitis. And previously they were using the current conditions, the current state of observational conditions to determine whether they had meningitis outbreaks likely. But with this sub-seasonal forecast data, we're able to extend that to have forecast information of those likely conditions to cause outbreaks. And that has a huge implication, because you have 2 weeks of extra preparedness time to make decisions around how you mobilize resources or people to address these red high vigilance regions. So that was one example of the subseasonal data. Another one in Kenya was using the subseasonal data, working with KMD, the Kenya Meteorological Department, and KenGen, Kenya Electricity Generating Company, to supply bespoke forecasts to support hydropower planning. So this is where Willis, our chief energy advisor planner at KenGen, was able to use the subseasonal forecasts of rainfall to determine his dam levels. so that he could make sure he had enough water to continue supplying hydropower for the region, but not so much that dams were likely to overflow and cause flooding downstream. And if he had forecasts of very heavy precipitation coming, he would have to have a controlled release to make sure that there was no flooding. So during the time of the testbed, he was able to show that it was uninterrupted power supply for Kenya during that time, and we didn't need these diesel generators. So really a strong case study that having reliable weather information at those extended lead times, provided you can turn it into something useful that's applied to a decision, can really have a strong influence. Then there was a large team in Ghana. So with GMET, those involved in the sub-seasonal part of SWIFT. So SWIFT was across different timescales, and many were involved in the nowcasting testbeds and various other parts of the whole project, but involved in the sub-seasonal part. And linked to the Ministry of Food and Agriculture, we were supplying forecast products for that sector. And in terms of precipitation, looking at tercile-based forecasts, the weekly precipitation and exceedance of probability forecasts. So trying to understand particular levels of what an extreme means for an agricultural context and applying that. And also developing the TAMSAT alert soil moisture products for Ghana. And this is something I'm keen to pick up on. And this, these products are still available. So we need to work together to make sure that this information can still be made available. There's some of this is in a paper that I wrote for weather, and some of the discussion around this Ben Lamptey has got in a very recent paper in Nature Communications about what the larger scale vision is for the future of African forecasting. We learned an awful lot from this process. So I'm just going to talk a little bit. Some of this is captured in the 21 paper, but a bit about some of the lessons that were learned from this process. So a co-production approach makes the forecasts much more actionable, appropriate, reliable, but it's also very resource intensive. So it needs to ensure, if you're hoping to take this approach, you need to ensure that there's sufficient resource to support the process. That means resource to support the early relationship building stages, resource to support the iterative dialogues that are needed to have that continued discussion. Maybe capacity building of all the groups involved, and that means strengthening decision makers' understanding of key forecast concepts, but it also very much means enhancing the forecast producers' or researchers' ability to effectively communicate technical concepts and to appreciate that there's a lot of information from the local context from forecast users in that region, and that knowledge is just as valuable to inform how forecast is developed. So a lot of capacity building in terms of a co-production approach generally, and ensuring everybody is willing to listen and be informed by others around that table. And then I think we learned a lot about evaluation. We were doing this real-time sub-seasonal forecasting testbed, and new forecasts were being produced every week, and we were for all of those different case study operational groups across different regions with different large-scale processes involved. So there was a lot going on, and I think we probably didn't have enough time or resource to really think about the evaluation effectively or with enough depth. And key to that is that decision makers should be involved in that evaluation process, not just looking at a meteorological verification of forecast skill, but trying to understand whether those forecasts products as they were delivered were actually able to support a particular decision. So a lot more of the user decision makers evaluation needs to be incorporated there. And we tried to summarize this in a policy brief, so you can go and have a look at it. You find it through the SWIFT website or here at this link, around how you can institutionalize co-production of services so that you can do it more effectively. And there's a lot of information in there around systems, around relationships, capabilities, and some of that is around data access, which I know can be an ongoing frustration. So very happy to pick up on any of these points, but I think I'll let you read through that one. So for the future, I think I'm really won over to this as an approach because it shifts the emphasis from being supply driven to being demand led, but it does involve strong relationships, lasting partnerships, and if those new services are going to be sustained, it has to have access to the data continued as well. And this is something I've been advocating really strongly at the WMO level for national Met services to have free access to that data. And just some examples of where user-directed iterations really changed the forecast so they were more actionable. So being able to combine variables for the health warnings for meningitis, for example, rather than having each of those variables separately, you're able to combine those and look at combined forecasts to support a particular application. Within the data manipulation, having direct access to the data for national Met services means you can do your own thresholds, right? You don't need to be relying on somebody somewhere has defined a threshold. You can use those appropriate for your sector, for agriculture, or varying that threshold across your region. For Ghana, for example, you might want something very different in the north to the south. And visualizing your output. It's useful to have the local knowledge and context to be able to visualize that in a way that is, appropriate for the region. And we had examples where even just adding county boundaries, you're not changing the data that's being visualized, but adding county boundaries made them more accessible locally because people could understand where they were within that spatial map very easily. So just simple examples, but this is really powerful, having direct access to the data so that you can make these changes. And I'd love to talk about that a bit more, but I'll carry on. So SWIFT follow-ons. So we're still trying to develop the energy stuff. At Reading, working with we have a strong Met energy group at Reading who do a lot of work on understanding energy markets in Europe. So I think there's huge potential to apply some of that understanding to the sub-seasonal context and forecasting that we started in SWIFT. And I'd been interested in exploring what that looks like in other regions, including Ghana, for example. And the meningitis work is being taken forward as well. So some of this is being moved forward to develop the scientific information going into that. So before, for example, we were just using the ensemble mean forecasts of those variables, but now we can explore some of the variability within the ensemble to understand a bit more about forecast uncertainty and how that influences. And here's a bit more information about that particular project, but I think I'm happy to answer specific questions of meningitis stuff if that comes up. Is working with World Health Organization partners across the meningitis belt. The TAMSAT alert is something that I'd really like to highlight again here, because I know that was started during SWIFT with GMET partners, and I'd love to know who, if anyone, is still thinking about this in GMET and whether this is something that we could develop into becoming operational, because it's the data is there. TAMSAT alert now has new soil moisture predictions as well as rainfall. So I think there's a huge amount of potential there to develop what is available. There's a new project starting, which is kind of sort of a SWIFT follow-on, but mainly focusing on East Africa, but this is thinking about some of the similar sub-seasonal impacts, particularly floods and cyclones, with focus countries of Ethiopia and Madagascar. And there's a new job at ECMWF just come up related to that, and one at Reading coming soon. And the next phase of the sub-seasonal to seasonal prediction project, which is the project that gave us real-time access during the testbed, is called SAGE, so Sub-Seasonal Applications for Agriculture and the Environment. This starts this year and goes through to 2028. And for those of you who've been following as part after SWIFT, there was a recent announcement by ECMWF that the subseasonal data is now going to be available, not at real time, but with a 48-hour delay. So for context, within SWIFT, we were already working on a 24-hour delay because we had to process the data. So 48 hours is still useful for decisions. So this data is now available again. So I think there's a lot of work that could be done to try and re-operationalize some of those things that were started in SWIFT to make sure they can be continued, given that this data is now available. And this is sort of the umbrella that this fits under. And Steve Woolner at Reading, who is my boss, is the co-chair of this new SAGE group. Happy to answer questions about that. But SAGE really is trying to acknowledge the whole value chain of the forecast. So rather focusing just on the underpinning science, trying to understand which is around the initial conditions, the forecast system, the forecast output, maybe the impact model as well. We're trying to add that extra part around the application and where forecasts are being used. Okay, I'm coming towards the end. A few more opportunities to highlight. So I'm co-leading an African case study within the Explaining and Predicting Earth System Change WCRP Lighthouse activity. So I don't know if any of you were involved in the WCRP conference in Kigali earlier at the end of last year. But basically this is still being shaped. It says East Africa here, but it doesn't need to be. There could be West Africa studies. The important thing here is that there are simulations out there ready to be analysed. So if you have students or PhD students looking for data to analyse these large ensemble single forcing MIP experiments, men are available with the data available. So that could be a way that we could discuss potential collaborations to develop a West African case study here. Happy to talk about that. So just to summarise, I think I'm coming towards the end. I think that we are only going to be developing appropriate, accurate and actionable climate services when we really explore how skill overlaps with usefulness. So this is how our sources of predictability, our regime-dependent skill, our key understanding that comes from local forecasters, the key understanding that comes from the underpinning large-scale drivers that I've talked about, how all of that leads to windows of opportunity, windows of forecast, higher forecast skill. But using a co-production approach to ensure that that can be used in an appropriate way to support decisions and build resilience, and really taking this iterative approach where you continue to move around this cycle of building common ground, of exploring, of co-developing and delivering solutions, and then ensuring that you evaluate those and iteratively change them. And one other thing that I just mentioned is that I find it difficult when there's a need to move away from these cycles of project initiated services. So I can think of examples during SWIFT where services were started because we had access to the data, and we had access to the data because of that project. Now that project was good in itself, but it's difficult if those services stop and are not sustained beyond that project. Because what do we do afterwards? You lose the trust of partners, you lose the trust of the users who are relying on those forecasts. So we really need to think bigger than this and think of a way to have sustainable services that are not linked to particular projects. And I really rally for this and have contributed to a white paper for the government on making sure this is thought about in those terms, in terms of sustainable services, and also worked hard to advocate for national Met services at the WMO level to have access to that data, which has now come. But of course we need to think about how we make use of that, because just saying the data is available doesn't suddenly mean that national Met services are in a position to make use of that data or have the computing facilities or expertise to immediately make use of that data. So I think we need to think a bit about how we can partner with universities. And I think my role at NCAS, so in the National Centre of Atmospheric Science, is quite nice because it's not linked to a university research institution. It's a national capability UK funded organisation where we do have that long-term partnership available. So I'd be interested to hear people's ideas around how to take those collaborations forward. With that, I think I'm going to stop and say thank you. That's my email address if you want to get in touch about any of the things I've talked about. But I also thought I'd just put up here some pictures for my time when I was based at KNUST. So I was very thankful to share an office with Leonard during that time. And it feels like a long time ago now. Very thankful to have been there. So yeah, I'll take any questions. Thank you.
All right, thank you very much, Dr. Aaron. We appreciate you, and it's very insightful, and we are grateful. This time around, we are going to open the floor for questions. So if you have a question, you can type it into the chat box, you can raise your hand, and also we will give you the space to talk. So I can see one hands up. Abdul Aziz, please, you can unmute yourself and ask your question.
Good morning, everybody. This is Abebe Abdulaziz from Asekna in Niamey. You are mentioning subseasonal and seasonal forecasts. What is the link with the seamless forecast? That is the first question. Regarding the drivers, I'm an operational forecaster, and I've noticed the impact of the North Atlantic Oscillation on the seasonal forecast and even the forecast, the daily forecast. What do you think about it? Thank you.
Thank you. Good questions. So the first one is around how the subseasonal fits into seamless prediction. So I did many National Met Services weren't using a subseasonal forecast, so would have had the short range forecast and then a seasonal outlook. So I think the subseasonal sits really nicely between what's happening on the short range and what your seasonal forecast is suggesting. And I think one of the things is key is to try and link that together in terms of a narrative, because it's really hard as a user if they see a subseasonal forecast showing a very different story to a seasonal outlook. So linking that with your extended seasonal outlooks is really important as well. Many modelling centres run a seamless approach where they have the same dynamical core running for all of the timescales. And I think that's helpful because then you've got your same model producing your forecasts on different scales. Related to the NAO, I think there's some really nice, one of the first papers is by Christophe Cassou, which shows a really nice link between the MJO phases and the NAO, or large scale regimes in the North Atlantic and the MJO. And I think that's quite a nice way of visualizing the link between how tropical modes of variability are interacting with extratropical modes of variability and the teleconnections through which they could potentially be influencing. But I'm sure that you would see an influence of the NAO potentially, and that would be modulated by which phase of the MJO you were in as well.
All right, sure, thank you, Dr. Aaron. I also have a few questions to ask. So the first one is, does the MJO affect the influence of ENSO over an area?
The short answer is yes. So they interact, definitely. A typical example is that you might have, if you have an El Nino developing in the West Pacific, and then you have an MJO propagating eastward through the equatorial Indian Ocean, it tends to cause westerly wind bursts, and associated with those westerly wind bursts would be oceanic downwelling Kelvin waves, which would tend to deepen the deepen the thermocline and increase the amount of warm water in the Pacific. So you might have a strong MJO strengthening an El Nino event. How those, I think one of the things I'm really interested in is compound events. So how they combine. And this is it's an interesting challenge because we don't have, if you're thinking about interannual modes of variability that don't happen every year, we don't necessarily have a long time scale to think about. And for example, you often get El Nino events at the same time as positive Indian Ocean dipole events, but trying to separate those or think about which parts of the problem are linked to both or one can be a challenge. So I think we can use extended seasonal hindcasts to increase our time, to increase our statistics so that you can look at more events.
All right, sure. Please, I see your hands up, Mr. Samuel. You can unmute yourself and ask your question.
Yeah, thank you so much, Linda, for the great presentation. It's just a comment and then a question at the end. Concerning SWIFT project, SWIFT project was one of the projects which has a lot of revenues after the project was over. For example, as we are seeing now, the virtual seminar series, it was something that was implemented by the SWIFT project. And when it comes to the JMET, also using the NWC stuff that the now satellite facility. It's also one of the tools that is being used now for nowcasting. And then also when it came to the Tansat alert, it's also something which we are currently in the hydro unit trying to use to help us in the soil moisture forecast, in relation to drought. So it's really a very good thing. One question I really want to ask was related to the large scale drivers. I don't know whether you've answered that one already, but it relates to which of these large scale drivers have very high influence over West Africa. That's the IOD, the NSU, and the MJ.
Which of those drivers has the largest influence over West Africa? Is that the question?
Exactly.
Yeah, thank you for highlighting all the things from SWIFT. I think it's one of my favorite parts of that project was the informal weather discussions, because I learned a lot from forecasters in different regions about the things that they would track in relation to their interpreting their forecast. And thank you for highlighting them all. I think it's a lot of good things that came from SWIFT. In relation to the large-scale drivers influencing West Africa, so the Indian Ocean dipole is more strongly influencing East Africa, and particularly during the short rains, the October, November, December rains, so has less of a clear direct influence on West Africa. There are a nice set of papers linking the role that the MJO has on modulating African easterly waves, which obviously very important for that West African region. So there is some large scale influence there from the MJO in terms of how it influences the African easterly jet and how that would then influence African easterly waves. Some of the work coming out of colleagues at CEH looking at the role of the land surface. So the land surface soil moisture conditions around where MCSs develop across the West African region and how that might be linked also to the MJO or modulated by the MJO. So I think it's complex, right? There's lots of different large scale drivers acting on different timescales, combining at different times. So I don't have a very simple answer, but I think probably on subseasonal timescales, we would definitely see the influence of the MJO.
All right, thank you. I just also want to comment on the currently in operation, we are using the impact-based forecast for our daily time scale forecast, and then it's very, very helpful, and our stakeholders are very happy about that.
Brilliant. I'd love to hear more about it. I feel like maybe I need a visit to GMET.
All right, so the floor is still open for question, but whilst we wait, Dr. Herons, can there be a significant change in the sub-seasonal forecast? Let's say a forecast that is lasting from 2 weeks to 4 weeks, then midway to the 4th week, there can be a significant change. Is there a possibility?
Yeah. The short answer is yes. This is one of the challenges of extended range forecasting, because you can see a change in the ensemble spread. You can see a change in the way, we might have thought that the MJO was going to develop into the Indian Ocean and have a really strong amplitude at lead time 1 and 2, but then as we get closer, it turns out that that's weakened and is no longer showing a strong amplitude, and therefore the influence on the forecast. So yes, it does change. This is one of the real challenges with how you communicate for sub-seasonal forecasts to users. There is a lot of uncertainty.
Okay, to add on to it, I was also contemplating if localized system can also have an impact on, let's say, sub-seasonal forecast.
Say again, sorry?
Can there be an impact of localized systems or events on the forecast, the sub-seasonal forecast?
Yeah. There's a cascading influence across scales. So you could have, you can envisage the MJO modulating horizontal and vertical shear and influencing where local scale systems were developing, but you could also imagine local scale systems, if they've developed, then they might create better preconditioning for the propagation of the MJO, for example. So you could envisage the influence going the other way as well. Yeah.
All right. So thank you. So there's a question in the chat box, and I would like to ask on behalf of Mr. Allen. Most forecasting services in Africa use forecast data from global models available, such as Central Africa. I don't know about West Africa. However, these models suffer from lack of representativeness of large-scale forcing factors, most due to poor SST, that is the sea surface temperatures, and so the diagnostic variables are poorly represented. In the absence of reliable data, enabling the models to be better parameterized, could integration of the water and energy balance in the forecast not improve the forecast?
There's a lot of things in that question.
Yeah, sure.
So I think to improve forecasts, we need a range of methods, and a lot of the operational centers, there's a huge work at the Met Office, for example, in the UK around developing convective scale models for Africa. So where you're not relying on parameterizations, but you have your convection explicitly resolved, which means you can your model has a very high resolution to develop those systems, and some indications show that those forecasts are able to get a much better diurnal cycle, so the rainfall at the right time in the day, better land sea breeze, but they also have different struggles and are still forced by the large scale boundary conditions from the parent model. So I mean, I think you need a suite of approaches to understand this, from high resolution, convective permitting, and if I don't know the specific model that you're referring to, but if it's due to poor SST, then maybe it's nudging that model with your observed sea surface temperature conditions or known conditions from a large scale driver or whatever it might be. So I think you need a lot of different approaches to really understand this.
Oh, all right, sure. Thank you. I hope Mr. Len's question is being answered. Please, the floor is still open for questions. So if you have a question, you can still ask whilst Doc is available.
All right. Thank you very much. I think you had a nice presentation, and I was actually fascinated about the story you gave about Kenya, where they are using this forecast to regulate the water level in their dam. And I think it will be very important to replicate same over here in Ghana. I'm sure you heard about the story we faced last year about the dam spillage. And so I wish you, in addition to what you are doing with MOFA, the collaboration you have with MOFA in Ghana, you could add that part also to it, the sub-seasonal forecast, so that we could better predict how much water will be gotten into this, the main dam in Ghana, which is the Kusumbo Dam, so that will not be caught off guard as it happened last year. So I think you're doing a good job, and you should keep it. Thank you very much.
Thank you for the comment. Yes, I followed that closely. I visited the dam there before, and I was sad to read about it. But I think there would definitely be potential here. Sometimes the challenge is knowing exactly. Sometimes the challenge is resource. Sometimes it's knowing who to work with. So I think we could combine with our connection through GMET to make sure that these new forecasts could be applied to that application. Yeah.
All right. Thank you.
Please, the floor is still open for questions. If you have, you can raise your hands. You can type into the chat box. Yeah, hello. Please, you can go ahead and ask your question.
Yes. Dr. Enda, can you go to the last slide? Where you said the need to move away from cycles of project funding, which projects? Yes. I was just thinking, just like we were commenting the SWIFT, definitely there was some limitation to data accessibility, especially implementing the sub-seasonal focus, right, through the SWIFT project. I think currently it's not functional, and it's something which I think if projects are initiated and they end, and then that is the end of it's being operationalized, it becomes a problem in terms of data accessibility, because I know they were running model based on the data availability from the UK Met Office or something of that sort. So after the end of the project, that was it, and it's not being implemented currently. So I'm seeing this as something that is challenging, which needs to be addressed.
Yeah. Wholeheartedly agree. This is why I've been. So one of my biggest challenge in the SWIFT project was that we had that real-time access to the data for a test period of 3 years. And after that, it stopped. And that is really hard for building any sort of sustainable service with a user, really hard for a national Met service to maintain the trust beyond that time because your data has gone. So I totally agree. And I've been working really hard from the banging on all doors that I can to try and advocate for that data access for national Met services. And this is why I'm really excited by the recent announcement. I'll find it and put it in the chat. The recent announcement about the data, because it does mean that data is now accessible again, and we can now build services that can be sustained because it's not going to disappear. The downside, of course, is that maybe we're not. The benefit of Swift was that there was a project that was able to support the process of doing that, and now maybe that is less that potentially could be done through NCAS, through the organisation I work for, in terms of supporting GMET to ensure that they are in a position to be able to access that data when it is available. But I mean, feel free to make a suggestion, Samuel.
Sure, I think it's something that needs to be addressed very, very well, because as we want to see the meteorological institutions being able to do well to give very good focus. This project aims to help the various main institutions. So it's not just this project; it's just an example. So if in future projects, driving at sustainability is what is incorporated in such projects, I think it will help very, very well. Because this one was a very good product that now it's not being operationalized.
Yeah, and it was not operationalized because of things that were out of the project's control, like the WMO. But since the project end, we've worked really hard to get those back within our control. But now the data is now available, but now the momentum is lost. So I completely agree. I think all projects need to build in an aspect of exit strategy, or the way that you plan to ensure that services initiated during that project are sustained beyond the lifetime of the project.
Sure,
Thank you very much. And please, there's a question in the chat box. Kevin is asking, with data stimulation, can the Swift also help build capacity, which will not only base or be limited to personnel reading PhD?
What? I'm not sure I follow that question. So which data available? Are you able to clarify that question?
Okay. I can't also address the data issue because I don't know which data he's talking about. But maybe he's trying to ask of the person whether it is made accessible to everybody or to people reading PhD.
So one of the things I mentioned around data, I'm going to put it in the chat now, around simulations, is the large ensemble single forcing simulations. And this is that paper that I've put in the chat is what describes them. You can see, I could probably find that live as well, a link to which simulations. Well, if you're interested in analysing those simulations, then you can get in touch and we can make sure you have access to those. So those are large ensemble single forcing runs, which would be a bit more about looking at the longer time scales. So it's not a forecasting simulation, it's like a climate length integration. The ECMWF data forecast, subseasonal forecast data that I've talked about within Swift is now going to be available through the ECMWF website. So you can download it and look at it there. Yeah. I'm not sure if that's addressed the Eben question, but
All right, so I'm sure you probably rephrase it. And Alan is asking again, is there a particular method to choose ensemble members that can be involved in the forecasting over a particular region?
To choose ensemble members within a single model's ensemble, do you mean?
The question he is trying to ask is that, is there a particular method to choose ensemble members that can be involved in forecasting over a particular region?
I mean, you'd want to look at a bit more detail about why you wanted to pick particular ensemble members, because the point of having an ensemble is that you're able to capture the potential spread of what could happen. So you can weight those ensemble members potentially, depending on whether they've got the earlier forecast conditions correct. But I think I'd have to understand a bit more about why you wanted to look at particular ensemble members, because it might be that for regions, I guess you might be thinking about regions where you have higher forecast uncertainty, so larger ensemble spread. Is there a way to reduce that ensemble spread by choosing particular ensemble members? I mean, on sub-seasonal timescales, we have quite small ensembles anyway, so you don't really want to be throwing away many of the ensemble members. You could make sure you look beyond the ensemble mean. So don't always just put everything as an ensemble mean, but understand a bit more about the spread and use a probabilistic approach.
Oh, all right, sure. Please, the floor is open for questions. So if there are further questions, please, we can still ask. I assume there are no further questions. I think we can bring the meeting to an end. Thank you very much, Dr. Linda Harris, for being available for this seminar. We really appreciate it, and we are still looking for it. You said maybe you could find your way coming to Ghana, so we'll still be waiting for you. Anytime you come around, JMET is available, and our arms are open to have you. I'm also appreciating everybody that was able to make it on board today. We are really grateful for your appearance on the seminar. And also, people were asking about how to get the seminar video. Please, the seminar video will be sent to those who registered via the email link. So once it is edited and done, we are going to revert back to everybody that registered. And also, the next seminar is going to be in next month, which will be happy if everybody could log on and also join for the next month. Before we bring the meeting to a close, I would like everybody to also turn on their cameras so that we could take a group picture before we end the seminar. And so on my count of 3, we take the first one, and on count of 3, we take the second one, Chief. So please, if we could turn on our cameras. All right, so 1, 2, 3, say cheese.